Okay, so we've got a problem here, and it is to find the derivative, and I'm assuming it wants the derivative function. So because again, there's always sort of some confusion, or not confusion, but the language might seem a little bit unclear because because we are kind of sloppy when we use the language sometimes. You can talk about the derivative at a single point, and the derivative at a single point will be a number because the derivative, the derivative is the slope of the tangent line. I mean, if you give me a point, if you're finding the derivative at a point, then you get a number because that number will be the slope of the tangent line. But then the other thing you can do is you can find just a derivative function, and that function will not be a single number. But what that derivative function will then be is it'll be a function that if you give me any point on the curve, then that function will tell me the slope. But it won't actually be a number, it'll be a function. And so sometimes or often we're not very clear and we just say find the derivative. But the assumption is if you don't give me a point, if someone says find the derivative and they don't give you any point, then the assumption you should make is that you're supposed to find the derivative function. Okay, so let's do that then. Okay, so this is the definition of the derivative. So it says that the f prime of x, so that the prime notation means derivative. So f prime of x is the limit as let me see here, as h goes to 0 of f of x plus h. And okay, and this is just the regular f. So f prime is over here, but this is regular f minus f of x divided by h. So this is the definition of the, you might, if you wonder where does this weird formula come from, the answer is that's the definition of the derivative. It's we are declaring the derivative to be equal to this. And the reason is because if you think about it, if you watch the videos, this is the formula, this limit is the formula that will give you the slope of the tangent line. So, okay, so then now what we have to do is we have to simplify this. So the idea is you say, well, wait, what's f? Okay, well, I didn't write it down, but f is the function that you're given. So, all right, so this limit I can rewrite as the limit as h goes to 0 of, okay, so let's see. So what is f of x plus h going to be? So f of x plus h is going to be, well, maybe I should write it over here just to be more clear. So yeah, what is f of x plus h going to be? Well, it's going to be the same f function, but everywhere I see an x, I'm going to replace it by x plus h. So I should have the square root of -5 times, and so instead of x here, I'm going to write x plus h. And then and then don't forget there's also the plus 1. But the plus 1 is not getting multiplied by the 5, so it's separate. So that's what f of x plus h is. So, okay, so I'm just going to write that down. So we wanted to know what was f of x plus h, and now we know. So, all right, so it's going to be -5 times x plus h, and then plus 1. And now I have to subtract f of x, and then f of x I just have right here. So I'm going to subtract the square root of negative 5x plus 1. And then we divide by h. Okay, so this right here is the limit that I have to compute. So let's see. So I can get rid of all of this because I'm probably going to need lots of space for this. So okay, so this is definitely not an easy limit to compute. And well, first let's just check. We should always do the easy thing first. So try the easy thing. And the easy thing is to plug in h as 0. And if you plug in h is equal to 0, well then this will just be the same as this. And so you'll get 0 in the numerator. And if h is 0, then you get 0 in the denominator. So you get 0 over 0. So and 0 over 0 is never a correct answer. So again, you should always try the easy thing. And the easy thing is just plugging in the number. But I guess you don't plug anything in here because it's h that's going to 0, not x. So wherever you see an h, replace it by 0. But you should try that. But most of the time it doesn't work. But sometimes it will work. And so on those times that it does work, you'll be very happy you tried it because that's the easy thing to do. But most of the time it won't work, and it didn't work in this case. So okay, so what does that mean? So what that means is we have to do algebra in order to simplify this. So let's see here. So whenever I see a limit that involves square roots, the thing I think to do is I think to multiply by the conjugate. So I'm gonna put remember that there are always invisible parentheses around the numerator and the denominator of a fraction. So just to emphasize that, so we don't forget about the invisible parentheses, I'm gonna make them visible. And what I'm gonna do is I'm gonna multiply the top and bottom by the conjugate. And so if you have an expression, well, maybe I'll just write it down and then we can talk about it. So the conjugate is going to be the square root of negative 5 times x plus h plus 1. And then plus the square root of 5x plus 1. So the conjugate, when you have an expression involving a square root, the conjugate is what you get when you just change the, if it's a minus, change it to a plus. And if it's a plus, change it to a minus. So if you have the addition or subtraction of a couple things, at least one of which is a square root, then the conjugate of that expression is the same expression, only change the sign of the operation in the middle. And now you have to be careful. If I just multiply by this red thing, I'm cheating because this red thing is not equal to 1. So if I just multiply by this red thing, that would be wrong because I'm not multiplying by 1. So you have to make sure, so that you're not cheating and you're not changing the problem, you have to make sure to multiply the top and the bottom by the same thing. So I got to multiply the top and the bottom by this conjugate thingy. Okay, so now this red thing is equal to 1. So it's legal to multiply by 1 because that doesn't do anything. And now something nice is supposed to happen. So when we do this multiplication, let's see, something good should happen. And what should happen is, okay, so we've got the limit as h goes to 0 of, okay, so when I do, I have to do FOIL. When I multiply in the numerator, I have to do FOIL. Okay, so but the FOIL is going to work out really nicely because when I do the f in FOIL, the square root, these are the same thing except with square roots. Or no, wait, these are the same thing. And when you multiply two identical square roots, then the square roots just knock each other out. So we'll just get a negative 5x, a negative 5x plus h plus 1. And there's no more square root because the square roots knocked each other out. All right, and then, oh, by all means, please, if you have any questions, you know, just let me know right away. Or type something in the chat window, because this is a lot of heavy algebra here. And so if you see something that looks suspicious, it is possible that I made a mistake. And so make sure to draw my attention to it, because we don't want to have me make a mistake early in the problem and then not find the mistake until the very end and then have to go back and start over. So if you see anything that looks fishy, please let me know. So that we can address it. Okay, so that's the f in FOIL, and and then let's do the L in FOIL. And you might say, well, wait, what about the O and the I in FOIL? Well, we'll get to that in just a minute. But if we do the O in FOIL, or no, not the O, the L, the last one times the last one. Well, again, the last and the last are the same. Oh, actually, I see a mistake already. I see my own mistake. It's a very minor mistake, so it'll be easy to fix. But this should be these both should be -5s. So I just forgot a minus sign. So when I do the L in FOIL, you got two identical square roots being multiplied by each other. So the square roots are going to cancel, and we'll just have a negative 5x plus 1. And oh, and I should say this is a hard problem. So those of you, if you haven't started doing this homework assignment yet, you might say, oh my gosh, this is going to be so hard. So yeah, well, this homework assignment does definitely have some hard problems on it, like this, but they're not all this bad. And then let's see. Oh, okay. Then when these things got multiplied together, one of them is a minus and the other is a plus. So that means I need a minus sign here. So, all right. So in other words, yeah, when these two guys got multiplied together, their square roots, the square roots knocked each other out. And so no more square roots. And there we go. And okay, but now you say, well, wait a minute, Travis, what about the O and the I in FOIL? So the O and the I in FOIL are actually pretty cool. This is what's neat about the conjugate. So let's look at the O and the I. So here's the O. So it's going to be this yellow thing times this red thing. And here's the I. The I is this guy times this guy. And those are, so the O and the I are the same, except for a minus sign. Because if you look at what the O, and maybe I should write it down. So here's the O, that's the letter O, and here's the I. And these are the letters in FOIL. So when you do the outside things, you get this long square root times the shorter square root. And when you do the I, you get the long square root times the shorter square root. So the O and the I are the same. Oh, wait, that's not quite true. They're almost the same. The O is positive because both of these square roots are positive, but the I is negative because this square root it has a negative in front of it. So the point is that the O and the I in FOIL knock each other out. The O and the I in FOIL, this is the cool thing about the conjugate. And hopefully you remember this from pre-calculus, that the cool thing about multiplying by the conjugate is that the O and the I always knock each other out. So that's the good news. The bad news is that they don't knock each other out in the denominator, because in the denominator there's no other conjugate. It's just this guy right here. So the bottom, the denominator is going to be this complicated. In the denominator, I'm going to have to write this big, long, complicated red thing again. So just hang in there. It takes me a long time to write. I got a new tablet, and my tablet is very sensitive. So I have to write very slowly. Otherwise, I look like a first grader who's just learning how to write. Okay, all right, there we go. Oh wait, I forgot something. I forgot the other parenthesis. Okay, so when we're all said and done, after we've done that nasty FOIL business, this is now what we're left with. Okay, so we're still not done yet. So that's the bad news. We're not done yet. But the good news is we're close to being done, because let's actually, I think we can simplify in the numerator, because let me see what I have here in the numerator. If I distribute this multiplication, let me think, well, maybe I should just, yeah, if I distribute the multiplication, I'm going to get a negative 5x and a negative 5h, right? Because when you distribute that multiplication, you get a negative 5 times an x and a negative 5 times an h. Okay, and now let's look at what we got here. What color should I use? Here's a negative 5h, and here's a negative 5h. So the point is that this 5, did I say h? I meant to say x. So this negative 5x and this negative 5x, they're going to knock each other out. They're going to make 0 because I've got a negative 5x here and a minus 5x here. So those guys will knock each other out. And then what else do we have here? Here we have a positive 1, and here we have a minus a positive 1. So those 1s are going to go away also. So if you're careful about simplifying, what you'll see here is you get the limit as h goes to 0 of, okay, so the only thing left in the numerator is this negative 5h. So we have a negative 5h. Everything else in the numerator ended up canceling when we simplified the numerator. And then the denominator, we still have this big mess. But it's about to get better soon. believe it or not, we're actually almost done. So, okay, so in the denominator, I still have this big old nasty square root, -5 times x plus h plus 1 plus the square root of -5. Oh yeah, that's the other thing I should say is, you know, this is why you never try to do these problems in your head. Don't try to do these problems in your head. Don't think that there's some sort of fancy shortcut. The best way to do these things is to just show all your work and be very careful. Actually, we will get a fancy shortcut later in the semester, but for right now, we don't have any fancy shortcuts. So this is what we got. Okay, and now a good thing happens, because I've now got, if you look at this, I have a factor of h in the numerator and a factor of h in the denominator. So those h's can knock each other out and make 1. So those h's go away. And let me see here, do I want to, I'm running out of room, but maybe I want to make sure that we all understand what's happening here. So I'll show one more step, or maybe 2 more steps. But okay, so I got the limit as h goes to 0 of, okay, so now we just have a -5 in the numerator. And in the denominator, we have all this red stuff. Okay, so we've got -5, okay, we got a square root of -5 times x plus h plus 1. And then plus the square root of -5x plus 1. Okay, we're almost done. We're almost done, I promise. You still hanging in there, by the way? You're all very quiet.
Been helpful so far.
Okay, good. I'm glad to hear it. Okay. Now what you might say is, okay, well, now what, Travis? What are we going to do now? I don't think there's a way to simplify this, and there's not. There's no way to well, yeah, I guess you could multiply by the conjugate again, but that would just take you back to where you started. So so this, I don't think I can make this, I don't want to make this any simpler. And so you say, well, how are we going to finish the problem then? Well, now remember the number one thing to try. The number one thing to try is always try plugging in the number. So we tried that at the beginning and it didn't work. So we tried plugging in h is equal to 0 at the beginning, but that didn't work. But now it will work. If I now plug in, let's see, what color do I have? If I now plug in h is equal to 0, so I can now say, if I put in h is equal to 0 there, oh, and that's the only one. There's only one h left in this expression, and I can set that h equal to 0 now, because that's what the limit is, and I won't get 0 over 0. I'll actually get an answer. And so I think we're done. So let's see what I get here. So what I'm going to get is I'm going to get -5 divided by the square root of -5x plus 1. And you say, well, wait, what happened to the h? And the h is gone. So I don't need these parentheses anymore if that h is 0. And then but then don't forget about this guy. There's still another one. There's still plus -5x plus 1. Okay, and then that's it. I would say that that is my final, well, I guess you could simplify that a little bit, but I don't have any more space left on my screen, and the computer should accept that. This is the correct, this is completely correct. You can simplify it a little bit, but I don't want to. Or like I said, I'm out of space. It's a minor, okay, now that I've talked about it so much, I have to simplify it. So what happens, just notice these two things are the same. These two square roots are the same. So if you add 2 copies of the same thing, that's the same as multiplying by 2. So I could, the simplest answer I could give, or the answer that involves the least amount of typing or writing, is -5/2 times the square root of -5x plus 1. Okay, so that's, I'll circle that too. So again, these are the same thing. These are the same thing, because the idea there is you've got 2 copies of the square root, and so if you add 2 copies of the same thing, then you've got 2 copies of that thing. So all right, so whew. That was a doozer. So that was a good question. That was so if you can handle that question. So yeah, make it your goal. Make it your goal to understand how to do this problem. Because if you can do this problem, then you could probably do any problems on the homework. Because like I said, this is kind of probably the hardest kind of problem that you're going to see on your homework. So what was the, let me think, let me give you the general, what were the big ideas? The first big idea was to use the definition of the derivative. So that's this guy. So everybody should have this formula more or less memorized. By the time you get to the end of module 6, you should have this formula memorized, because that's the formula for the derivative. And then we had to use so when we used the formula, we got this really terrible limit. And then so we had to do a dirty trick. And the dirty trick, when you're dealing with a limit that has square roots in it, then multiplying by the conjugate is a cute algebraic trick that often works. And it did in this case. So we multiplied by the conjugate, and then we just had to do a whole bunch of algebra. And then after we did that algebra, then we wound up with an expression where it was safe to plug in h is equal to 0. And once it's safe to plug in your number, then you're done. That's kind of how limits work. In practice, the way limits work is you try to plug in the number, and usually if you get an answer, if you get something nice, then you're done. But what usually happens is you get 0/0. So what usually happens in the limits in this class is when you plug in the number, you wind up with 0/0. And so when you get 0/0, that means you got to go through and do all this algebra. So let's see. So there's a question in the chat about if we aren't given a specific value of x, then do we always plug in 0? So, well, the answer is you always plug in your limit number. So that the reason I'm plugging in 0 is not so much, it doesn't have so much to do with x or anything else. It's just that the limit is as h goes to 0. So that's why 0 is getting plugged in here. So you always follow what the limit is. And in the definition of the derivative, the limit will always be 0. If you use this definition of the derivative, the limit will be 0. So I hope that made sense. Okay. So the answer is, maybe said another way, is if you're finding a derivative, then yeah, then you're going to set h equal to 0. Because that's what the derivative will always be, h goes to 0. But if you're finding some sort of other limit, then you might have to plug in a number other than 0. But you just always follow the directions that the limit says. If the limit if the limit said h was going to 10, then I would put a 10 here. So just do what the limit says. Let's see, problem given a reflection, what is the derivative? Oh yeah, okay, great. Yeah, we got another derivative problem here. Okay, so but before I do another derivative problem, I have to erase all of this. And so before I erase all of this, any comments or questions about this? I should take a picture. All right. Not exactly sure where these pictures go, but they'll go somewhere. Oh, wait, I should pause the video.